Hi, I'm Robbie Stewart, a graduate from Carleton University's paleontology program, and today we're going to be talking about Cenozoic crocodiles. Picture this. The scene is 25 million years ago. The giant dinosaurs like Tyrannosaurus rex and Triceratops have all been extinct for 40 million years. But the Earth still shakes with the footsteps of giants. Not of sauropods or hadrosaurs or tyrannosaurs, but rhinos. Giant rhinos the size of a brontosaurus. These rhinos had massive metabolic constraints. They needed so much food to keep them stable, to keep them alive. They were constantly looking for new trees to strip vegetation from. A group of these rhinos, maybe a herd, maybe a family, is wandering through a lake that to them is no more than a pond. The waters surge with their massive footsteps as they wander through this lake like it's a pond or a puddle. Suddenly, the youngest of them cries out and then disappears beneath the water. It's in the jaws of a giant reptile, a crocodile the size of a bus. The age of the dinosaurs exists only in the birds now. The age of mammals is just beginning, but the age of crocodiles never ended. 25 million years later, paleontologists will dig up the skull of this giant rhino and find the tooth marks from the crocodile embedded in its skull all this time later. Though crocodiles reached gigantic sizes in the oceans of the Jurassic and the rivers of the Cretaceous, it's here in the Cenozoic that they actually reached their biggest sizes ever, and they spread out into all kinds of different niches just like they did in the Mesozoic, barely skipping a beat after the asteroid impact happened. The Dinosaurs, who we left last time, relatives of phyllitosaurs like Sarcosuchus and Elasuchus, have survived the asteroid impact. Not only have they survived, but they're the biggest predators that have survived the extinction event. 6-meter-long Dinosaurs are still swimming around the coastlines of South America after the meteor struck. Aramborgiosuchus, a 6-meter-long crocodile living off the coastlines of South America, survived the extinction event. Unlike any other oceanic predators, the 15-meter-long mosasaurs and the giant plesiosaurs that had been its predators and competitors had all gone extinct, but Aramborgiosuchus remains. Scientists believe that dinosaurs were able to survive where all of their competitors died out because they'd actually returned to fresh water to lay their eggs. These less salty habitats, like lagoons and estuaries, would have been natural nurseries for these tiny crocodiles to grow up into full-sized predators. But this also meant that they were naturally insulated from the meteor disaster. When the meteor struck, it blotted out the sun, which killed all of the algae that formed the basis of the ecosystems in the oceans. But the ecosystems in freshwater are founded on decaying matter being processed by small insect larvae. There was plenty of decaying matter after the destruction wrought by the meteor. Most things were dead. And so the freshwater ecosystems remained mostly intact. So the Dinosaurs could dip into the freshwater ecosystems and then come back out when it was finally time for marine ecosystems to rebound. And this gave them the unique position of going unchanged between the boundary of the asteroid impact before and after. There were no other marine predators left in the oceans. This gave them room to expand. By 15 million years later, Phosphatosaurus, a gigantic dinosaur, was the biggest predator in the oceans at 9 meters long. The golden age of the dinosaurs wouldn't last though. Their competitors began to catch up with them again. There were other animals that had survived the boundary. The Otodus genus of gigantic sharks had started out small, but in these oceans they were getting bigger and bigger. Eventually, they would reach the infamous Otodus megalodon, the biggest shark to ever live, which would achieve lengths almost twice that of Phosphatosaurus. But even here in the post-impact waters, they were already 6 meters long, worthy competitors to the Dinosaurs. Snakes had also survived the asteroid impact, and they too could easily return to the waters just like the crocodiles could. Gigantic sea snakes began to haunt the oceans of the Eocene. Whales, too, were entering the oceans by the time of the Eocene, when the Dinosaurs were starting to see the height of their success. Protocetids, strange, surprisingly close relatives of entelodons, which looked sort of frog-like, but had these long alligator bodies with these frog-like legs, were actually whales, early whales, covered in body hair, with jaws just like an entelodon's. These were getting more and more adapted to the water as the Eocene passed. Eventually, they'd lead to some of the largest creatures to ever live, like Parusetus. But for now, they were still small, but still competing for the same supply of fish that the Dinosaurids were. Just like before the asteroid struck, the oceans were now filled with competitors, and just like before the asteroid struck, the Dinosaurids were now in the middle of the food chain rather than on top. This was a terrible time for disaster to strike, but disaster did indeed strike. All of these competitors compounded with a sudden spike in ocean temperatures, which caused a turnover of plankton. And this time the Dinosaurs weren't so lucky as they had been during the Mesozoic. For whatever reason, they went extinct by the time of the Middle Eocene. And with them, the Tethysoukians, a 100-million-year-old family that had once dominated the waterways of Asia, Africa, and Europe, were no more. By the time of the Oligocene, the gavialoids had spread from the Tethys, where they got their start in the Cretaceous, into the expanding Mediterranean, even as the Tethys was shrinking, and began to radiate in two different directions all over the oceans of the world. By the time of the Miocene, they were in the Caribbean. But even after the Tethysoukians went extinct, modern-day crocodiles would continue entering the oceans again and again and again. While the modern-day gharial of India and Nepal and the false gharial of Southeast Asia live entirely in freshwater systems, the gavialoids actually spent most of their time in the oceans throughout the course of the Age of Mammals. The first gavialoids existed at the end of the Cretaceous period, and just like the Dinosaurids, they survived the extinction event. Unlike the Dinosaurids, they began to spread all over the world as they diversified. By the time of the Oligocene, a gavialoid called Achetogavialis had made its way all the way to Puerto Rico from Europe. And by the time of the Miocene, that same species of gavialoid had swum all the way around South America to make its way to Venezuela. Some of these ocean-going American gavialoids were giants. Thecachampsa, a 6-meter-long gavialoid, had made its way both to Virginia and all the way up to California as well, swimming across the entire Gulf of North America. Keep in mind, North America and South America weren't joined together at this point, but this was still a gavialoid that was swimming all the way around the oceans coast to coast of the isolated continent of North America. At 8 meters long, Piscogavialis of Peru was even bigger, the largest of the gavialoids to swim in the oceans. And it was even more specialized for catching fish than its modern-day relatives are too. Modern-day gharials can have needle noses that are 3 times as long as the rest of their skull. But Piscogavialis could have a 4 or 5 times as long snout relative to the rest of its nose. And further, they would have extremely long teeth about the size of a person's thumb, all specialized in skewering fish and catching them. At the same time that there were gavialoids that were going west, there were also gavialoids that were spreading to the oceans of the east. By the Miocene period, there were gavialoids in Taiwan. And by the Pleistocene, there was a giant gharial in Japan called Toyota Maphemia, which could grow up to 7 meters long and traveled the farthest north that any gavialoid ever has. Almost all of these gavialoids, both true gharials and false gharials, went extinct as the Cenozoic progressed. In particular, the South American clades were hit very hard by the upheaval of the Andes, which rearranged the river systems of South America and started changing how the waters of South America were dumping out. Remember, Most of the crocodiles that we've covered actually would return to freshwater in order to lay eggs. And since the freshwater rivers were now all dumping out into the cold waters of the Atlantic instead of the warm waters of the South Pacific, the crocodiles that depended on them were suddenly finding the habitats too cold for their eggs to survive. There's evidence that Piscogavialis survived a few million years into the Pliocene after the heat maximum of the Miocene began to shrink. But as the march of the ice ages pressed on, they started to go extinct more and more rapidly all around the world. Toyotomephemia, already well adapted to the cold oceans of Japan, held on for an extremely long time, all the way until 30,000 years ago in the Pleistocene. Can you imagine that? Crocodiles in Japan as recently as 30,000 years ago. That was long after humans had evolved, and the first humans were already spreading their way into Australia and North America at this time. But eventually, it too was knocked out by the last of the ice ages, the coldest one yet, and so no gavials survive in Japan until the time of human habitation. There was, however, one of these ocean-going gavials that survived long enough to bump into humans. As the colonies of diverse gavials that had survived in the oceans of South America were dying out, they pulled one last trick. They actually rode the currents from Peru all the way to New Guinea, across the entire Pacific Ocean, and there, in the warm and tropical waters of New Guinea, they survived all the way until 6,000 years ago. Tentatively identified as Icanogavialis, this last of the gavials survived all the way until the end of the Pleistocene, when it's thought that humans traveling to New Guinea were actually the ones to finally wipe it out. That was the last of the ocean-going gavialoids, and one of only 2 species of falsgarial to exist. All of the surviving ones live in the warmest parts of Southeast Asia, and all of the surviving ones are freshwater creatures. Even today, both of them are endangered, and the gavial in particular is critically endangered, with only about 300 of them left. But modern crocodiles do still swim through the oceans. We all know the famous saltwater crocodiles of Australia. So marine are saltwater crocodiles that they can spend days at sea, long enough to accumulate barnacles like whales can. Fish and sharks actually make up an important part of their diet. And here in the Americas, there's actually another species of crocodile, the American crocodile, which spends much of its time in estuaries, salty lagoons along the coastline. American crocodiles can swim so far that they've actually colonized all of the different Caribbean islands. And in fact, even when they've been extirpated, wiped out in an area by humans, they actually sometimes have been found swimming their way back to the islands from other groups of islands. The Grand Cayman Islands hadn't seen an American crocodile in 200 years, but recently there have been reports of them off the North Shore. These aren't natives that have miraculously reappeared, but appear to have come from Cuba, all the way across the ocean from Cuba, having swum that far in order to try to colonize these lands with no competitors. Saltwater crocodiles and American crocodiles are some of the largest crocodiles alive today, both of them growing to be at least 6 meters long at their biggest, some of the most powerful predators that are alive today. The way that they're able to swim through the oceans is that they have specialized salt glands on the bottom of their tongues, which they can use to leak salty water from their mouths to prevent themselves from being overwhelmed by the ocean's salt supplies. None of these crocodilians, whether the modern ones or the fully marine ones that existed in the Cenozoic before them, were nearly as adapted for the waters as the Thalattosuchians of the Mesozoic. The Thalattosuchians were evolved so that they could actually hatch their eggs internally, you might remember. Every species of ocean-going crocodile from the Cenozoic had to return to dry land in order to lay their eggs. They were not entirely marine animals. They only spent most of their lives in marine waters. And even then, the ocean-going crocodiles that we have today are not specialist marine animals. But while the crocodiles who survived the Cretaceous extinction were not perfectly adapted to the oceans, on land they fared much better. Terrestrial crocodiles were actually more successful in the Cenozoic than they ever had been in the Cretaceous. And in the next presentation, we'll see just how successful they got across the entire span of the Age of Mammals, all the way up until they were meeting humans. We actually got up close and personal with some saltwater crocodiles at Little Ray's Reptile Sanctuary, a natural conservatory for reptiles that had been seized from irresponsible pet owners in Ottawa, taking care of them while we try to find a good home for them. While we were at Little Ray's, we saw a gigantic saltwater crocodile and got the opportunity to enter into the tank while they were feeding it. Here we can see just how well adapted to the water they are, but also how they have to stay on land for at least part of their lives, never actually spending their entire time out in the water.